Okay, here is our first scale model problem. Madison and Centerville are 6 centimeters apart on a map that has a scale of 1 centimeter to 11 kilometers. How far apart are the real cities? So with these type of problems, we always start with what is given. And what is given is the scale. The scale is going to be key to these questions. There's the ratio. So for every 1 centimeter on my map, that represents 11 kilometers in real life. So I'm going to start out with that ratio and turn it into fractional form. And the model that I'm going to use is model over actual. When I'm doing these type of problems, I'm always going to use this as a model, as my template to help me figure out my proportion. So let's take our ratio, our scale that's given, and plug it in to this template, to this model. So in my model, in this case it's going to be the map, I have 1 centimeter represents 11, I'm looking for the actual, kilometers. And here is my scale. And I'm always going to start with the scale when I do these problems. Notice, model is 1 centimeter, actual is 11 kilometers. Okay, so we've started with that. And what we're doing here is we're creating our proportion. This is just going to be the left side. So I'm going to say equals. So now I'm getting to the problem and trying to figure it out. How far apart are the actual cities? So the actual cities, is that going to fall into my actual or my model? We got to figure that out. Well, let's look at this up here. Madison and Centerville are 6 centimeters apart on a map. So that right there is my model. So that's where I'm going to fill in my centimeters, my 6 centimeters. And again, this is why it's so important that we're including units and we're making sure they lined up. I wouldn't put 6 centimeters down here because that doesn't line up with my kilometers over here. Now, the other part makes sense. How far apart are the real cities? Well, that's going to be X because we don't know. But we know that it's going to be in kilometers. So here now is our proportion. And like with most of these proportion problems, the most difficult part is setting these up, making sure that the numerators and the denominators are correct and that my units line up. So after I've set up my proportion, now I need to solve for X. And the way we solve for X during proportion problems is we look for a relationship first to make it easier on ourselves. Is there a relationship between our known numbers? 1 and 6. And I encourage you to pause this and think about it. What are we going to multiply or divide to get from one to the other? And what we're going to do, there is a relationship, and that relationship is multiplying by 6, because we know that 1 times 6 is 6. Once we've established that relationship up top, we're going to apply it down low in my denominator. We're also going to multiply by 6. So this just becomes, hey, what is 11 times 6? That's going to give us our X. Well, I'm going to do a little scratch work over here and multiply. 6 times 1 is 6. 6 times 1 is also 6. So my final answer is 66. But 66 what? Well, let's look to what we were trying to solve for, X kilometers. So we know that it's 66 kilometers. So going back to our original problem, in a map where the scale is 1 centimeter to 11 kilometers, if on that map the cities are 6 centimeters apart, in actuality, in reality, they are 66 kilometers apart. That's it.